This video is about theoretical and experimental probability. By the end of the video, you should know the difference between the two and be able to use experimental probability to predict future events. So theoretical and experimental probability are a little bit different. Theoretical is what should happen in an experiment. Experimental is what actually happened. So let's take, for example, flipping a coin 50 times. Okay, so theoretically, it should land on heads half and tails half. So it should be 25 times for heads, 25 times for tails. That would be the theoretical probability because that is what should happen. Now you actually sit there and flip the coin 50 times, and let's say it landed on heads 40 times and tails 10 times, then it's going to be not the same as theoretical. So it didn't happen 25-25, it happened 40-10, so that was what actually happened. That is experimental. Okay, we're going to use this same chart for two different questions, this one and the next one. So if you want to make this chart, pause the video and make it, and write this first question down, and then you can unpause it when you are done and ready to move on. Okay, so a spinner with 3 equal sections is spun 60 times. What is the experimental probability of spinning a red? Okay, so first of all, it tells us that we are spinning it and we spun the green 21 times. So you make tally marks, you count them up. It was 21 of tally marks of green, 15 tally marks of blue, and 24 tally marks of red. Okay, so we know that the total is already 60 because they told us that in the question. Okay, and we care about the red. So on the chart, it tells us that red was spun 24 times out of the 60. So we are going to make a fraction. Now remember, it doesn't tell us in the question to simplify, but we always simplify when it says probability. It's implied that you have to do that. So if we take half of each, we have 12 over 30. Take half again, we have 6 over 15. We cannot take half again because we have a 15 in the denominator, but we can divide both of these by 3. So 6 divided by 3 is 2, and 15 divided by 3 is 5. Always remember to check to see if you can divide by 3s. I know a lot of people forget that and they just stop at, well, if you can't divide by 2, it's as simplified as you can go. So always check 3s. So what this means, 2 over 5, we can't simplify it anymore, is that every 5 times that you spin the spinner, 2 of the times it's going to be red. Okay, so same chart, same information, but now we are comparing the theoretical and experimental probability. So we just figured out experimental probability was 2/5. Okay? Theoretical, so in a perfect world, if there are 3 sections that are all the same size, we should land on each section 1 out of 3 times. Okay, so when we are comparing theoretical and experimental, we are going to change these to decimals just to compare them. This is giving us 0.4. This gives us 0.33. These are still pretty close together. So we're going to say that the experimental and theoretical probability are close. So you're going to write this as a single sentence. So anytime it says compare, you're going to write out a sentence. Okay, so we're going to use this chart for 1, 2, 3 questions. So again, pause the video, make this single chart that you'll use all 3 times, copy down this first question, and then go ahead and unpause it when you are done. Okay, so it says last year's sales at the Buy More DVD store are shown. What is the probability that a customer bought a comedy DVD last year? Okay, so first of all, we need to add up all of these because we don't have a total in our problem, in our words. So if we add all of these up to know how many was sold, we would have 2,000. Okay, and in this case, we just care about the comedy. So we have 580 over 2,000. So remember my trick about zeros on the end, we can just cross those off. So really we just have 58 over 200. If we take half of each of these, this gives us 29 over 100. Okay, and then 29 is a prime number, so the only number we could divide by is 29, and we cannot divide 100 by 29, so this is our final answer. So what this means is that if you were to break it down, every 100 DVDs sold, 29 of them would be comedy. Alright, suppose the media buyer expects to sell 5,000 DVDs this year. How many drama DVDs should she buy? So again, our total is 2,000. So we're going to put that on here. And out of the 2,000, we care about drama. She sold 450 out of 2,000 was drama. So we want to know how many out of 5,000 would be drama. So we're going to do our cross multiplying, get this done. So we multiply 450 times 5,000. It's going to give us a really big number. 225,000,000. And we're going to divide that by 2,000. So use your trick again. You can cross off the zeros. So really in your calculator, you just need to type in 2,250 divided by 2, and that gives us 1,125 DVDs. Okay, so why is this important to be able to do this? So if you own a business, you want to be able to make the most amount of money possible. So this person who owns this store is going to look at, maybe this is the numbers from last year. So last year they sold 670 action movies. Okay, so this year, if they want to make more profits, they're like, okay, I think I'm going to sell about 5,000 this year. Movies are doing better. So how much action movies should I buy, or how many drama should I buy? So in this case, we'll talk about drama since it's on here. She wants to buy 1,125 DVDs. Okay, so if she only bought 400 DVDs instead, she's going to lose a lot of money because all these people wanted those movies and they don't have it, so they would lose it. Okay, if she bought, let's say, I don't know, 5,000 of them were all drama, then she's going to have all these extra movies sitting in the back of her store that no one wants to buy. So again, she loses money. So she wants to figure out what's the best number she should buy, and this is going to be it. Okay, if the media buyer expects to sell 3,000 DVDs this year, about how many action movies should she buy? Okay, so she thought, well, 5,000 was too much. What if I just bought 3,000? How many of each should I buy? So again, our total, because it's the same chart, otherwise we'd be adding these all up again. It is 2,000. So we want action, so that is 760 over the 2,000 equals x over 3,000. So when we multiply 670 times 3,000, that gives us 201,000. We're going to divide this by 2,000. So cross off those zeros. So really you're just typing in 2010 divided by 2, and that gives us 1,005 DVDs. Okay, so again, she's predicting she wants to sell 3,000 compared to 2,000 the year before. So she needs to buy more action DVDs, but she needs to know how many more DVDs she should buy. Okay, so she's going to buy 1,000 instead of just 670. Okay, so now it's up to you. Go ahead and stop the video. Try this question. It is all related to the same table. Alright, so if we add up all of these numbers, we have a total because that's what we always do, find the total, of 114. Okay, so it says, what is the experimental probability that a student's favorite color is blue? So we have 52 over 114. Okay, so if we take half of each of these, this gives us 26 over 57. Okay, so we can't divide by anything else because the only thing we could divide by is 2 and 13 for 26, and we can't divide that by 57. So this is our final answer. If we want to compare it to the theoretical, so in theory, since there's 3 colors, that would be 1 out of 3 should have been blue, which is 0.33. This one, if I just write it up here, was 0.45 when we divided 26 over 57. So these are a little bit further apart, so I would say they are close, but not very close. That would be my sentence for that one. Okay, if you were to ask the entire school of 540 students about how many would say their favorite color is green. So right now we have 34 out of 114 like green, so we want how many out of 540 like green. Okay, so if we were to do our cross multiplying, that'd be 34, sorry, should have been 28. 28 times 540, that gives us 15120, and we're going to divide that by 114. Okay, so this is not a whole number. This, if you type it in your calculator, it's going to tell you 132.6, but these are people. You can't have 0.6 of a person, and it's closer to 33, so we are going to say 133 students like the color green. Okay, so this is it. Thanks for watching.